Am I audible?
Yes, sir. Yes.
Good morning. So, yesterday we have started this interference in the involved gears. So, which is the phenomenon wherein the tip of tooth undercuts the root on its mating gear, and that phenomena we are going to call it as interference. So, then it will weak the wheel at its root. Then this is the animation. This one, the slide, which indicates the damage to the tooth due to the interference. So this way there is damage to the tooth. Okay. Then you have drawn this diagram. Then we are going to see once this interference is avoided. That means this radius of addendum circle. So initially it is O1L. Give me 1 minute, please. Just I will admit. Okay. So when this radius of addendum circle, that is O1L. So this one is the addendum circle. It is increased up to this. That means now new radius will be O1N. And if this radius is increased beyond this N point, that means O1N, that is the limiting radius of the addendum. So once again you can check this animation. Okay. So this blue one is the addendum circle. This is the addendum circle, and you can consider this as a maximum addendum circle. So whatever shown here. If beyond this point, if radius is increased, then there will be interference. There will be interference. So when the interference is just avoided, now whatever line diagram shown up to this N point, so O1N, it is the radius of maximum addendum circle for the pinion, and this O2M is maximum radius of addendum circle for the this wheel. Okay. When interference is just avoided, so initially we have seen this KL, that is length of path of contact. Now when interference is just avoided, this MN is nothing but maximum length of path of contact. Maximum length of path of contact. So in the previous diagrams we have seen this KL is nothing but length of path of contact. Now what I am saying, this is N and this is M. So through this M, the addendum circle of the wheel is passing. Through this N, addendum circle of pinion is passing. Those are maximum addendum circle. And this N is the last point, this M is last point from this side and from this side M. So beyond this point, if addendum circle radius is going to be increased, then there will be interference. एकाच गिअरला किंवा एकाच व्हीलला दोन अडेंडम सर्कल नसतात, एकच अडेंडम सर्कल आहे. बट फॉर द कन्सेप्ट, this one is the maximum addendum circle and this is the actual addendum circle. हे दाखवलं इथं. So to have the clarity, so this is shown. So up to this we can draw the addendum circle. Now once this radius it increased above up to this n point, so this O1n is nothing but the limiting radius of addendum circle of the pinion. O2m is radius of maximum addendum circle for the wheel. So these are the limiting radius. Accordingly, we have this mn, one segment, and which is called as the maximum length of path of contact. Now this maximum length of path of contact, again it is divided into two parts. One is maximum length of path of approach. Maximum length of path of approach. So first I will show. Previously this is path of approach and now this is path of approach. So just I will draw that figure. This is P point, this is K point, and this is L point, right? So this one is path of approach, and so I will indicate with different color another one line, and this red line indicates maximum length of path of approach. That means here I will write M. So this MP, here we have written this MP is nothing but maximum length of path of approach. Now how question will be asked? When interference is just avoided, what is maximum length of path of approach? There will be option R sin phi, R cos phi, R sin phi plus R cos phi, and none of this. Now this R sin phi, how we got this value? Now we need to consider this triangle O1 MP, O1 MP. This one triangle we have considered, this triangle. So here we can write sin phi is equal to this MP divided by this O1P, right? So what is O1P? O1P is nothing but this R. So therefore MP we are going to write as R sin phi. R sin phi. So this is the value for this MP. Okay. Similarly, we can write value for this PN. What is this PN? Maximum length of path of recess. And what is value for that? Value for that is Pn is equal to r sine phi. Again, you need to consider this triangle. Okay. So just by considering this triangle, here we can write sine phi is equal to this opposite side, that is Pn upon this O to P. So O to P is nothing but R, right? That is radius of peace circle for the wheel. So by putting value for this O to P, we can get this Pn is equal to R sine phi. Already I have written. Okay. Now addition of these two, that will give value for this Mn, right? So Mn is equal to, so this will be asked in MCQ, this MP plus this Pn. Okay. So directly by putting these values, we will get R sine phi plus capital R sine phi. So just I will display it. Okay. So Mn is equal to MP plus Pn, R sine phi plus capital R sine phi. Take out this sine phi as a common. What is inside the bracket? R plus R. Okay. Then this is length of path of contact, maximum length of path of contact. Again, length of arc of contact, it will also maximum. So then you need to write maximum length of arc of contact is equal to, this is length of path of contact, that we have written as it is, divided by cos phi, right? So again this sin phi divided by cos phi, that means it is tan phi. So r plus r tan phi. So when interference is just avoided, comma, maximum length of path of contact will be this r plus r sin phi, and maximum length of arc of contact r plus r tan phi. Understood? So this is interference in involved gear. So this value is of importance. This is of importance. This, remember this, and this. So only 4 out of this slide, right? So maximum length of path of approach r sin phi, small r sin phi. Maximum length of path of recess, capital R sin phi. Addition of these two, that will indicate maximum length of path of contact, and finally maximum length of arc of contact is equal to r plus r tan phi. Okay. Next, write down, to prevent interference, what is required? Now just see the animation. Okay, I have stopped. Now you can see that this is the tip of tooth. Now contact of this tip of tooth is taking place above this base circle. लक्ष द्या, नीट लक्ष द्या, right? And we are going to discuss this. The tip you are going to observe, it is having contact beyond this base circle, or this is having contact to the profile inside this base circle from that side. Check animation. So tooth on either wheel or tip of tooth on either wheel, they should have contact on the profile. Check करा. So the forms, gear tooth forms are made such that there should be contact on the profile only. On the profile only. Now here this one is the point, so I will write for your understanding. This is point N, this is point N, and this is M. Okay, so here already written, addendum circle cut the common tangent to the base circle at point of tangency. At point of tangency. This N is called as a point of tangency, plus this M is called as a point of tangency. And you can read this sentence also. Point of contact is always on involute profile. हा प्रोफाइल आहे, right? So this part is called as a profile. This part is called as a profile. Point of contact is always on the involute profile. Here also you can check. This is the involute profile. This one is the involute profile. इकडचा जो टूथ आहे त्याची जी टिप आहे ही कुठं फक्त मेश होती, ह्या एरियामध्ये, इकडं नाही, राईट? आणि इथे जर कॉन्टॅक्ट झाला तर देन देर विल बी इंटरफरन्स. नाउ चेक. सो व्हॉट इज फर्स्ट मेथड टू अवॉइड द इंटरफरन्स? That addendum circles cut the common tangent to the base circle at the point of tangency. And what is the second method? That point of contact is always on the involute profile. So this is required, so this may be asked in the MCQs. Okay, now so whatever we have discussed, that we are going to write in terms of sentences, right? Methods to avoid interference. Methods to avoid interference. Method to avoid interference. Right, number one, height of teeth may be reduced. Height of teeth may be reduced. Height of teeth may be reduced. Now here you can check if this is the height of teeth on the pinion. If we are going to reduce and this will be the final, what will happen? So there will not be any contact beyond this point. Again we are reducing. Now this is the case whereby interference is avoided, but till if we want, we can reduce, and this part can be removed in order to avoid the interference. Okay. Then next you can write second method, undercut undercut of the radial flank of the pinion. So just I will show you. This is the tooth. This one is the tooth. So I will try to draw. Okay. And this you know. This is flank. And this one is face. Right? Now, undercut of the radial flank of the pinion. Now, how to make the undercut? So just I will make it. Right? And here also I will make it. Okay, right? So the same animation. So this one is the flank, and we have made here undercut. This portion. Originally there was this is the curve. We have removed this many area from the original tooth. So you can check this. Okay. Or right. So this is the interference, and we need to remove this part. म्हणजे जिथे wherever interference takes place, so that part we are going to remove. हा एवढा पार्ट इथला रिमूव्ह करायचा. That will be considered as undercut. So undercut is due to the interference, and if before interference you need to manufacture the gear teeth such a way that inbuilt undercut we are going to provide to the gear that will avoid the interference. That will avoid the interference. Okay. Then next, write on number 3. By increasing center distance. By increasing center distance. By increasing center distance. So this is one of the method. One of the method. So suppose these are the wheels. We can move this blue gear in this direction and this one in this direction. So suppose this is the center distance initially. So we can have increase in the center distance that will keep this tip away from the root. So by this way also we can avoid the interference. Next you can write by increasing pressure angle. 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 This is the pitch circle. This one is the pitch circle, right? And this is common tangent to the base circle. Now, once we are going to increase the center distance, the imaginary pitch circle, so this will be as it is, but base circle is going to change its position, and now we will have another line. Just I will make it clear. This is the pitch point line we have drawn. This one is base circle, and this is the pressure angle. How to increase the pressure angle? This is new base circle. This one is new base circle. So I will just erase previous one. And now we will have another tangent. Sorry. This is increased pressure angle, right? But this is one of the method. Next you can write by tooth correction. Another method is through the tooth correction. By tooth correction, the pressure angle, center distance, and base circles remains unchanged. But tooth thickness of gear will be greater than the pinion tooth thickness. So another way to avoid the interference is just by tooth correction. So this is the tooth. So just we are going to modify its profile. That is nothing but the tooth correction. Other things we are going to keep constant. Pressure angle no change, center distance no change, base circle no change. But in this case, tooth thickness of gear will be greater than the pinion tooth thickness. That is another issue. Okay. Next you can write by tooth profile modification. So this number 4 and this number 5 are related to each other. By tooth profile modifications. By tooth profile modifications. So this may be asked for the descriptive question for your IAC number 1. State various methods to avoid the interference. Okay. Now next you can write, just take down title. Minimum number of teeth on the pinion in order to avoid interference. Minimum number of teeth on pinion in order to avoid the interference. In order to avoid the interference. In order to avoid the interference. Okay. So as there is a problem for this slideshow, just you can take Okay, so this is the figure. Here you can check, just to see first. So I'm going to provide the PPT in the PDF format. So actually I have given animation effect to this expression, but now it is not working. So this is the schematic diagram. Here you can see this side pinion, this side wheel, this capital R radius of pitch circle of the wheel, small r radius of pitch circle for the pinion. This one is the pitch point, this KPL. So here intersection point K and here L. This M and N, maximum limits or the points of tangency. Okay, so here P, what is the bit title? Minimum number of teeth on pinion in order to avoid the interference. So we need to define during the design. So this will, you are going to determine in the machine design too, wherein you have to design the gearbox. So there, by determining minimum number of teeth on the pinion in order to avoid the interference, that is the step which one is important. Now how to get the expression for that? So first we need to have nomenclature. So T as T small t number of teeth on the pinion, capital T number of teeth on the wheel, small m module of the teeth, then this small r pitch circle, radius of pinion, radius of pinion. So and this is equal to EMT by 2. How it is written here? So you know, just I will write this module is equal to D by T. Here we are going to write 2 times radius upon T. So how you can write? R is equal to EMT by 2. That is written there. Okay. EMT by 2. Similarly for the capital R in the next slide. Okay. So what is G? That is the gear ratio. Gear ratio is equal to number of teeth on the driven to the number of teeth on the drive, and which is equal to this capital R by capital R by small r. Okay. So this is the gear ratio. Phi, pressure angle, or we can call it as the angle of obliquity. This is the terminology. Now here you can see that various circles, pitch circle, actual addendum circle, maximum addendum circle. So already we have discussed in the previous slide, right? So these maximum addendum circle limits the radius for the pinion and limits the radius of addendum circle for the wheel, right? So this one is the limiting radius. Why I am telling repeatedly? Because we need to find out limiting radius. So please see this carefully, this expression. Okay, now we need to see the value of this O1N, maximum value आहे किंवा limiting radius of addendum circle. So this is the maximum addendum circle. This one is the maximum addendum circle. and we need to find out this O1N. So for that, we need to consider this triangle. What is that triangle? O1P1. O1P1. And here it is drawn separately. O1P1. Okay. Now this side as a, this side as a C, and this side as a B. So you need to use the cosine rule. Right? So with the help of this triangle, we can write, so this O1N, that means this is nothing but C square. This is nothing but A square. This is nothing but B square. And here 2 times A into this B and this angle. Right? C square is equal to A square plus B square minus 2AB cos of this angle. So what is the angle? So just I will, okay. So this angle, this is phi, you know, pressure angle, that is shown here phi, and here it is 90 degree. So 90 degree. So you can write the expression. So just I will enlarge its view. Okay. There is problem, huh? 1 minute. Okay. Okay. So this O1N square, that is C square, is equal to A square. That means this side O1P, that we have written here, O1P bracket square, plus Pn square, that means this B side, Pn square, minus 2 as it is O1P, again this O1P, and this Pn, that means B, and cos of this angle. So cos O1Pn इथे अँगल झालाय, राईट. 90 प्लस फाय, इथला अँगल किती असणार आहे? 90 प्लस फाय. सो अगेन फॉर दिस O1P, this O1P is nothing but radius of P circle of pinion. So we can put here R, that becomes R square. For the Pn, this is the Pn. So value for this Pn, R sin phi, from this triangle already in the last bit we have seen, by considering this O2Pn, sin phi is equal to Pn upon this O2P, right? So what is O2P? Capital R, and this capital R into sin phi, so that is nothing but Pn, and we have made here square, so therefore R square sin square phi, okay, minus 2 into O1P into Pn into cos O1Pn. So 2 as it is, O1P we can write R, Pn we can write capital R. Now cos of this O1P, that we have written cos 90 plus phi, cos 90 plus phi. Now check out next step. R square as it is, R square sin square phi as it is, 2 times R into R as it is. Okay, 2 times r into r as it is. So this we have taken as it is. Here previously sin phi. Now what is value of this cos 90 plus phi? That is nothing but minus sin phi. So for this minus sin phi, this sin phi minus sin square phi, because of this minus we can multiply minus minus, that becomes plus, and here we are going to get this plus 2 r r sin square phi. Okay, now simple step, you need to take r square as a common. So from this, if we are going to take r square as a common, make one bracket. What will be the remaining term here? 1. Again from this term, r square common. So r square sin square phi, here divided by r square. Again from this, r square common, 2r sin square phi divided by r. Okay. Okay. Now r square as it is here, 1 as it is. From these two terms, we can take r by r as a common. So here r by r as a common. What is remaining from this first term? R by r. Again we have taken sin square phi as a common. So that's why it is outside the circular bracket. And for this 2 and this 2 is only remaining, that we have written. So this r by r common from both of this term along with this sin square phi. So what is remaining here? This is the remaining r upon r plus 2 bracket complete sin square phi. Okay. Now next, this is the expression for this O1 n square. Now we need to write value for this O1 n. What is O1 n? That is nothing but limiting radius. Check out this. Limiting radius of pinion, addendum circle, or limiting radius of addendum circle of pinion. So just this O1 n square root we have taken for both the sides. O1 n, then for the right hand side r square, we will get r, and remaining bracket it should be under the square root. Okay. Now this O1 n is equal to value of r. What is value of r? mt by 2. mt by 2. Already we have seen. 1 as it is, r by r as it is, r by r as it is, plus 2 as it is, sin square phi as it is. Now this is limiting radius of addendum circle of pinion. Now you should remember that there is one standard whereby we are going to assume that addendum for the pinion is equal to 1 module. Right. So what is addendum? So this we have seen already. So just I will show you. This is addendum and This one is addendum. This is addendum and this one is addendum. Right? So this addendum is equal to one module. It is in terms of module. This one is the standard. Now, if I will write here one term and I will name it as AP into M, and here it is addendum. So instead of this, I will write 1 minute, so you will not have any confusion. So here I will write addendum. Okay. So AP is equal to 1. इथली व्हॅल्यू आपण 1 हे कशासाठी आहे, दिस AP साठी, and M as it is, right? So next, what we are going to write, let APM is equal to addendum of the pinion. Addendum of the pinion. So already I have shown you this is equal to, here there will be fraction and M. It may be 1 or it may be 1.2 depending upon the design. Okay. Now what is this AP? So AP is equal to fraction by which the standard addendum of one module for the pinion should be multiplied in order to avoid the interference. It's so that fraction may be 1, that fraction may be 1.2, right? So already I have shown you this is AP into M. What is this AP? Is nothing but the fraction by which standard addendum of one module should be multiplied. So its value, suppose I will take as a 1.2, then we will have 1.2 into M, right? So this AP is nothing but the fraction that we are going to consider. Okay. Similarly, instead of this, if minimum number of teeth on the wheel, then we are going to write there AW. AW means that is fraction by which standard addendum of wheel should be multiplied. Okay. Now, what is addendum of the pinion? Once again, I will show slide. So, this is the tooth. This is nothing but addendum. This is nothing but dedendum. How to find? Right? So, this is addendum circle and this one is the piece circle. So, here it is mentioned addendum of the pinion is equal to O1N maximum addendum circle radius. Maximum addendum circle radius. इथं जे addendum circle दाखवले त्याचं काय addendum circle radius? It is indicated by O1N, that is written, minus this O1P. So this part we are going to call it as a addendum. Now this O1N, we got the value of O1N and minus by this pitch circle radius. So just I am stopping. You are requested to enter your roll numbers in the chat box.